Okay, so in this video I'm going to show you how to find the residues of this function using the cover-up method. Now, two things you need for the cover-up method. You need this to be analytic, and then factors of this in the form of z plus or minus something. So trigonometric function divided by polynomial function. We know this is analytic everywhere. So for cover-up rule, we need analytic, so that is true, and then we can factor this, so we can get some function f, well in this case because we got the function is f, we call this g of something, z plus or minus that one, and z plus or minus that one, something like that. So they have to be single z's. So that's the rules to allow us to use the cover-up rule. So that's sorted. Now we need to factor this. Z squared minus 2z plus 3. How are we going to do that? Well, there's no clear factors in that, so we're going to have to resort to the quadratic formula. So we go straight in with 1, minus 2 and plus 3 as our values. So minus b is 2, so z equals plus or minus square root b squared minus 4ac. So 4 minus 4 times 1 times 3, that's 4 minus 12, so that's minus 8. And the a is 1, so minus 8 over 2. So then that equals 2 plus or minus, take the I out, take the minus out, and then 2 root 2 over 2, which equals 1 plus or minus I root 2. Okay, so these are our singularities. Okay, so that's the singularities. So as these are our singularities, they're also our factors, because we've got the plus and the minus, there's 2 there. So let's just put them into this function here. So z, and as this is a positive here, obviously all the solutions are all z minus 1 plus I root 2, and then multiply that by z minus 1 minus I root 2. This hasn't changed the value of this function here at all. We've just factored it out to get it in this kind of form so we can use the cover-up rule. Okay, right, I think we're ready to go now. So let's try doing that. So residue of f at 1 plus I root 2. Let's do that one first. Okay, so that, if we plug in 1 plus I root 2 into all of these, one of these is going to disappear as a 0 and it's going to leave the other one. So whichever ones are left, we'll do, let's say if this one disappears, it's then these two make the function. If this one disappears, then it's these two that make the function. So let's see how we get on with that. Sine of 1 plus I root 2. And then which one of these is going to disappear if you plug in 1 plus I root 2 for the z? So 1 plus I root 2 minus I root 2, that one is going to go to 0. So then we're left with this one. So 1 plus I root 2 minus 1 minus I root 2. Okay, let's work out what we got left here now. So sine 1 plus I root 2. 1 minus 1, 0. Real numbers disappear. We've got an I root 2 here and a minus minus I root 2 here. So now what we get is 2I root 2. Okay, let's see if we can get this I on the top and the 2, maybe we can do a factor of something. Let's have a look what we get. So 1 divided by I is minus I. So then that equals minus sine 1 plus I root 2. The I is now up the top. So let's put that up the top. And then divide that by 2 root 2. Okay, so that's our first residue. So that takes care of that one. So that's our first answer. Now let's work out the residue of the 1 minus I root 2. Let's just draw a line there. Residue of f at 1 minus I root 2. Okay, well we know we're now going to plug that in there for that, and then we know then it's going to be the plus I root 2 we're now to use this time because we used this one here. So that equals sine of 1 minus I root 2 divided by, plug in the 1 minus I root 2 as we did here for the plus one, so 1 minus I root 2, and then we're going to subtract 1 plus I root 2. So then that will give us sine of 1 minus I root z I root 2, apologies for that. 1 minus I root 2 minus 1 plus I root 2. 1 minus 1, 0, real numbers disappear. Minus I root 2 minus plus I root 2, so that's basically minus 2 I root 2. Okay, so I'm seeing a similarity to this one, except we have a minus sign on the bottom. So that becomes sine 1 minus I root 2 divided by, right, let's go careful here. So basically we've got 1 over minus I, which becomes positive I. So we can bring a single I up the top, positive. Then just leaves us 2 root 2. The minus I is taken care of by bringing just a single I up the top. So that then gives us 2 root 2. Then that gives us our other singularity. Okay, so these will give us our answers here. But let's see sine of 1 minus I root 2 and sine of 1 plus I root 2. So this looks like a double angle formula, so a quick little bit of algebra here. So double angle formula for sine of 1 plus I root 2 then becomes sine of 1 times cosine of I root 2 times cosine of I root 2. And then because it's a plus, we'll leave the plus in there, plus cosine of 1 multiplied by sine of I root 2. I'm sure we can fit that in. Let's just give ourselves a bit of space. I root 2. Okay, we can simplify this up even more. So then that equals sine of 1 cosh root 2. Cosine of I gives us cosh root 2 plus cosine 1 and give us a bit more space again. Sine of I root 2 gives us sinh of root 2. So now what we've gone to now, we've gone to a real value for sine of 1 plus I root 2 just by breaking it down into the cosh, the hyperbolic sine and the hyperbolic sinh. And then similarly 1 minus I root z, sine of 1 minus I keep saying z, it's actually a 2, I root 2 equals, so same as we're doing here, sine of 1 cosine of I root 2 again minus, same again, cosine 1 sine of I root 2, and then just by breaking down the sine of I becomes sinh and the cosine of I is cosh, so that equals sine of 1 cosh root 2, this time we have a minus, cosine of 1 sinh because it's sine and I, of root 2. So that it breaks down what our sine values are for these. So this one here, sine of 1 plus I root 2, you can substitute this in. And this one, sine of 1 minus root 2, which is this one, you can substitute this into your numerator. Okay, that completes that. Thanks for watching.